this. Okay, we're on now. Jeez. All right, it's Wednesday, or yeah, Wednesday. All right, so everyone understands how to do their challenges and turn those in, correct? All right. Another thing, I sent a message out to everyone. I think, Megan, I don't know if you got this one, because I don't know if you're on my group just yet. But the work has to be turned in the day that the work is assigned, okay? You can't turn it in another day, because especially on a day that we're supposed to be here. Like, let's say on a Wednesday or Thursday, Friday, and Saturday, you send some work in, and you're here too, okay? Unless it's the work that's been assigned for that day for those 2 hours, I can't accept those other ops or those other papers to get credit for it for that day. Does that make sense? Because it probably wasn't for that day, it was for another day, and you're turning it in and you're trying to get hours for it for that day, and I can't do that. Does that make sense?
Yeah, I understand.
Okay, if you're here, okay, I'm giving you the work that you do this day, okay? You can't clock in at 10:35 on the lab, okay, or on a zip whip and still collect hours there and here at the same time you're at school, because that was done a couple of times. So I just want to make sure everybody understands it. When you're here, you're getting the clock hours from here. That's where I take those hours from, okay? The ones that you do after school, okay, those are those 2 hours for that part. But the work that was assigned that day, if I said this is what you're supposed to do, that's what has to be turned in that day, okay? You can't turn it in later the next day and try and get credit for it. I just can't, because then it's going for 2 days, you're trying to get credit for it. You see what I'm saying? There's no way of tracking it that way. So I'm just asking that you make sure that you turn in what you're supposed to turn in on the day that you're supposed to turn it in. And it's usually just, you know, Tuesdays and Wednesdays, because that's the only days you guys are at home now, okay? So any other work that you need to turn in because it's late, it's just turning it in. It's not getting credit for it, okay? Does that make sense to you guys? Okay, because if you've been here all this time, you know what chapters we've gone through, okay, and what are supposed to be done. If you haven't turned them in, then I'm just waiting until you get it when it comes around again the second time. Does that make sense? Okay, because most of you turned in all your work, and I don't have to worry about it. I've got a stack of papers like this from all week, and then others I don't have it all at the same time. So I have to have it turned in, my boss said, otherwise there's no way to track it to the boards. Okay? All right, so yesterday it was your pH scale. Did you guys do your pH scales? Who did their pH scales yesterday? Okay. If, let's say, on a Tuesday or Wednesday, you did not sit through the Zoom class, okay, and you wanted to get credit for it, okay, because I give the assignment during the class, you have to watch the video and then turn in that work for that day in order to get credit for that day, okay, at least for the Zoom, okay. You may not get the 2 hours for the extra work, but you can get credit for watching the Zoom and turning in your work, all right. Okay, just want to make sure everybody understands how they're getting graded and how the hours are working. That way you know and you can keep up on that. Because I just turned in, basically I did half of the time cards, almost all of them except for about 3 of them. Then I have to go back and redo all the paperwork because it doesn't match. So I'm like trying to keep it together, all right? So that's why I said from now on, this week it's got to be whatever we're doing, that's what we're doing, okay? Are we good for that? All right. All right, I will bring back the other Zoom so you can watch with the slides, because this first part of it is kind of tricky, okay, as far as how much has to be put into your study guide, all right? So let me switch the screens again. And if my screen gets stuck, please tell me, because I can't tell. I'll just kind of go this way. There we go. Okay, so that's your slides. Okay, hold on. Wrong one. Okay. Aha, see how nice I am for you today? Does that help a little bit? Do you still have your slides though? Up. You do have your slides up? Okay, so this first part, I'm actually going to let you see what I see and what needs to go into that area on this study guide, okay? Because there's a lot of stuff coming out on like the periodic table. What's that other one that's like, goes through free electrons and molecules and things like that. I want you to be able to put all of that information in there. And it's a lot of information. If you were in class, I would have had to go through it very slowly so you can put that information in. But the good thing about this is that it's really not going to be this hard or difficult, because the chemistry that you need to know for your state exam would be on your pH scale. It's not really referring back to free electrons. Okay, let me show you. On the next page is going to get really kind of crazy and detailed. All right, you won't have to worry about that, so don't sweat that part. Nor is it on your exam for me, okay? Because I've written it out the same way that the state has, by breaking it down from that sheet that I gave you that said this is the state questions will be taken from this area of information. Do you remember when you first got it from me?
Yes.
Okay, I just want to make sure. Is that like the CIB, it's the California Information Bulletin? Okay, so if you want to, go ahead and start to fill this part in and I will just continue to talk. How's that? Does that sound like a plan until I get to the other half? All
Sounds
right.
good.
Okay, good. All right. Chemistry. This is your scientific study of matter, the physical and chemical changes affecting matter, and the energy that changes that accompany these processes. Okay. So basically, they're going to ask you a question that refers to chemistry, asking about matter. Okay. What is chemistry? The study of matter. That's all the question is going to be written. That's as simple as it's going to be. And a chemist is going to be a scientist who studies matter, its properties and changes. Okay. Biochemistry. Okay, this is the study of the chemical reactions such as growth, reproduction, and respiration that occur within a living organism. This is going to go back to your proteins and carbs, and calories, that kind of thing. That's where that's coming from, that they're talking about. Having to do with our bodies. All right, your organic chemistry deals with matter that is now living or was once alive one time. Okay, plants, obviously. But the study of matter containing carbon, that's your first clue. If it's alive and it has carbon, it's going to be organic. If it doesn't have carbon and it was never alive, it's going to be inorganic chemistry. The way I remember this is because I'm like one of those little nerd people that think there's aliens out there, right? But when the scientists at NASA go out and look for other planets, what they're looking for is to find out if there's carbon there, to know if they can actually grow something out there. Oh, and so this is basically the same thing. So I always remembered organic chemistry has something to do with being alive and containing carbon. That's the best example I can give you guys. All right, your inorganic deals with matter, again, that was never living or was not alive. And your examples can be rocks and minerals. Okay, I'm going to leave that up on the screen for a moment before I scroll down. If you guys are all finished, let me know, okay?
I'm finished.
Okay. I'll wait for the other ones for their little sound because I can't see you. If I change the screens, you won't have this on there. This basically is the one chapter that I'll put up on the screen. Are the rest of you still writing?
Yeah, no.
Done.
Go ahead. Okay, I'm going to scroll down a little bit. And this is going to be our classifications of matter. So matter is anything that occupies space. And it comes in three distinct forms. So the first one would be a solid. This is a matter with definite weight, volume, and shape. So they give you an example of human skin. I can even say it's the chair that's in the classroom or my desk, okay? It has weight, it has volume, and it has shape. Liquids are matter with definite weight and volume, but no shape, okay? Example could be skincare lotions, okay? And your gases are going to be matter with definite weight, but indefinite volume and shape. So an example is going to be air. Could also be hairspray in a can or something like, a deodorant in a can, something that works similar to that, where it's a gas and it does have weight, but it doesn't have volume and shape. And just let me know when you finish those three in there.
I think we're done.
Okay, you done, Griselda? Griselda, you still there? Okay, you're gonna have to hold it then if I change this page here.
Yeah, I'm done. Sorry. I have you on speaker, then I have to mute it.
Okay. So you were finished, I can change, right?
Yes.
Okay, good. All right. So changing matter, it can be changed from one form to another in two ways. Okay, your physical change is the change in a physical form of a substance without creating a new substance, possessing a distinct material composition. So again, the example here is freezing water to form ice cubes. And then if I let the ice cubes melt, I can always revert back to the liquid water. Okay, that's what a physical change is. Another one would be if somebody got their hair blown dry and it's all pretty, as soon as I get it wet and then restyle it, she has a different shape, but it's not permanent. Does that make sense? I can keep blow drying her hair and wetting it and blow drying it, and I can make different things happen to it, but I haven't done anything permanent to it. So a chemical change would be a change in a substance that creates a new substance with different material characteristics from those of the original substance. So an example on this one be the transformation of hydrogen and oxygen to form water. So if I look at it here, I would have to use a permanent to change somebody's hair chemically, okay, and then try and blow dry it. Well, I would never get the same thing before because I have a permanent now. It's actually completely different. Does that make sense? I was trying to give you a different example of that, but once it's permed, you really can't do anything unless you use another chemical to make it straight again, as opposed to just having her hair blown dry and then getting it wet and blow dry it again. She's basically has the different appearances, but it's still the same type of hair. Does that make sense? Or do you need another example, guys? Okay, you know I can't see you, right?
It makes sense.
Okay. Just want to make sure, because once I put the other screen up, I have no idea what's going on the other screen. All right, sublimation. This is a solid that passes into a gaseous state without melting. Can anybody think of something that might work this way? What about dry ice? Would that work or no? The solid passes into a gaseous state without melting, right?
Yeah, it would work.
Okay. And so I was trying to give you an example there. Okay, and energy. This is the ability to do work to accomplish some change. It's at the core of our chemistry along with matter. Okay. Elements. These are basic units that cannot be broken down into simpler substances by any chemical reaction. Pure substances, like 92 naturally occurring elements in nature, hydrogen and oxygen, are your examples. There's actually more than that, but at the time this textbook was written, it was 92. Okay. And why do you need to know these atoms and elements and all of this stuff? Is because it always reverts back to this when you're talking about skin, hair, and nails. Okay. So your periodic table, Dmitry Medieval-Levy, I'm not sure on his name, and Lothar Meyer identified ways to arrange elements with similar properties in groups in a table of elements. So the periodic law would have been the unifying concept that's used to organize these elements and their similarities. The letters, which are chemical symbols, serve as a scientific shorthand for each element. The number shown with each element is known as the atomic number and indicates the number of protons in a single particular element. This is a basis for its organization. All of that information, what I'm trying to get at is you don't need that for testing purposes, but I'm giving you the information to fill in your textbook. However, that next part at the bottom where it says elements of interest for estheticians, that is something that you do need. And that's carbon, oxygen, hydrogen, nitrogen, and sulfur. Think of it as the acronym COHNS, C-O-H-N-S, to help you remember it. Okay. 2 of those are a solid, and the rest are gases. Can you tell me which 2 are solids? Anyone?
You're asking which one of those is a solid?
It's solid. Yeah, out of the carbon, oxygen, hydrogen, nitrogen, and sulfur, 2 of them.
Sulfur and
Yep.
carbon, right?
Right, exactly. Those are your two solids. All right, I'm going to leave this up for you guys to fill this part in. Do I need to go back up so you can get the physical and chemical changes in there also? I can't even see shorthands, guys. I have to have a voice. So how are you doing?
I'm finished.
Okay. Do the rest of you girls need more time? You're
I'm
gonna
good,
have
Miss Judy.
Okay.
I'm
gonna-
good.
Okay. All right. I'm gonna flip it over to the next page here. This is like the really hard one right here to fill this in. Okay. And just an FYI, Megan, if you look at the top where it says chapter 7 chemistry and then it says the chemistry of matter, the information that is on this page is found right there at the top on the right hand side where it says 221 to 223, just in case you didn't know that.
Okay.
All right. So atoms are the smallest complete unit of an element, and each element consists of identical atoms. Okay, so your electrons are going to be your negatively charged, and it enables the atoms to unite with other atoms to form bonds. We go to the other side where it says neutrons, and these have no electrical charge because they're neutrally charged. And then your protons are going to be your positive electrical charge, and the number of protons differentiates one element from another. Okay, so there's a little box I think you need to fill in the equal where it says neutron plus a proton equals molecular weight. Okay, then you're going to the nucleus. These are protons and neutrons packed tightly to form dense core at the center of the atom. These electrons move around the nucleus at the speed of light on an orbiting path called energy levels. Again, not something for board. I don't know why they get this so detailed in here for you. Okay, then they go into this free electron. And this is going to take a little while to put this information in. So I'm going to move this up. Do you still need that rest of that up there, you guys, to fill this in? No answer.
No, I'm good. I have it.
Okay. Okay, then I'm going to move it up so that you can get the rest of the page in there. Okay. So your free electron is the chemical behavior or the reactivity of an atom depends mostly on the number of electrons present in the outermost orbiting path or shell. The name given to an electron in the outermost orbit that is easily moved from its orbit if another atom has a shortage of electrons. The free electron will try to move to that atom. Atoms not missing any electrons in the outer shell are considered stable and electrically neutral. Unstable atoms are reactive. Unstable atoms seek other atoms with which they can share electrons to complete their outer shell. When they combine, they make molecules. So it's just a very long definition to be put in there for you. And I have no other way of actually shortening that one. I can on my molecules, but I really can't shorten that free electron. And instead of me just reading it throughout the whole thing, I just let you see the whole thing and write it in there. And then your molecules are going to be when unstable atoms combine chemically, a molecule is formed. It's the smallest part of a compound that has all of the chemical properties of that compound. This is our example. Two or more atoms joined together by one or more chemical bonds. Atoms in a molecule are described using the chemical symbols of each element. An example would be oxygen is O2, which means the molecule has 2 oxygen atoms. You don't need to write anything in there except for the smallest part of a compound. Okay, and when atoms combine chemically, a molecule is formed. That's all you have to write in that particular area. Just be glad you only have another page of this, and then we can go back to the other screen. How are we doing, girls?
Done.
Good? Have you finished?
I'm done.
Oh, okay, how about everyone else? I'm gonna move the page if you're not gonna say anything. Speak up.
I'm done, Miss Janie.
Okay, let me make sure. Okay. This is the last part of this, okay? Seriously. All right. Compounds. These are created by chemically uniting two different elements. And more than 4 million chemical compounds exist. The compounds formed by the union of an individual element have their own unique chemical and physical characteristics. So all you have to write in there is created by chemically uniting two different elements. That's all you have to put in there. All right, under your chemical reaction, we do need to know something that regards this, okay? So reactions that occur in the outer shell of the atoms leads to the composition of a client's specific needs. This occurs when two or more chemicals are mixed together. Okay, so oxidation is the loss of an electron and oxygen is acquired. Reduction now is gains an electron and oxygen is released. Okay, both of those, oxidation and reduction, are test questions, just an FYI. Okay, now your ions are going to be charged atoms. So ions attract or repel each other based on their positive or negative charge. Okay, the ionic bond is when a positive and a negative ion join. They're held together by an ionic bond. Covalent bond, if no trading is taking place, the atoms are sharing the electrons and they're held together by a covalent bond. Your chemical bonds, forces that hold the atoms together in compounds. So once we're finished with this, we have a learning connection. Let me know when you guys have finished that particular part. See if it does. It doesn't have it on here, huh? Do you guys have a learning connection on your book? No.
Yes, we
Yes.
do.
You do? Okay, it just doesn't show up on here, huh?
No, it doesn't. I've left on the smart notes and stuff, but it doesn't usually show it.
Oh, okay. I was trying to figure out why they said that it did that. I'm like, that's kind of dumb. It's on the book, but it isn't on the smart notes. All right, are you guys finished with this page yet?
I am.
Okay, anyone else need it?
No.
No? Okay. So I'm gonna go back. I'm gonna stop sharing here. Okay. So Is that a little easier to fill that in that way? Some of you probably already had that filled in, but I left it up on the screen for a reason because that's really kind of hard to read all of that off to you. Okay, your learning connection has map the various forms of matter using the jumpstart box. Begin with the form of matter and define the form and give an example for each form of matter. So a solid would be, a solid would be, what's the definition of a solid?
Matter with definite weight, but indefinite volume and shape.
Correct. And what's your example?
Human skin.
Yep. Okay. And a liquid?
Matter with definite weight and volume, but no shape.
Correct. And your example?
Skincare lotions.
Correct. Good. And then your gases. What's the definition on that one?
Matter with definite weight, but indefinite volume and shape.
Good. And example?
Air.
Yeah, there you go. Okay. So basically we've covered this first part of it and I've kind of given you what you actually need off that information. Okay. Unless you're going to be a chemist, you really won't need that information. But then again, you could be a chemist. All right. What I'm going to do though is give you your break earlier today. Okay. So we'll see you back here at 12 o'clock. Okay. And then we'll go back to our book work. All right. See you at 12. Did we talk like last week about bringing in some type of product that you're using at home so we could check the pH on it?
Yeah, we did.
Okay, so if you bring it in tomorrow, bring something in, preferably a liquid, okay? Something that's water soluble. We can bring it in.
So just one product?
Mm-hmm. Just one. By the time everybody gets to them, we can just take the litmus paper and check it out to see if it's an acid or an alkaline. Because where do we want it to be? On the acid or the alkaline side? Where's skin, hair, and nails?
At
Alkaline,
4.5
right?
to
On the acid side, it's 4.5
acid,
to
yeah.
5.5. That's where you want it to be, yeah. You want it to be within the same pH as skin without raising it or lowering it so that it maintains the skin. Hi. Is everybody back? One more. Oh, there's Megan right there. Sorry. There you go. There you go, Megan. Okay. Megan, when you're doing this, do you have a way to be able to do your computer and your phone at the same time?
My other laptop broke. I ordered a new one. It's supposed to be here today.
Okay. Because what happens is, like, I know this sounds kind of crazy, but if you can watch slides on one and fill in your workbook on the other, it actually helps you.
Yeah, I know it's a little hard on my phone, but it should be here today, so I'll be able to have a computer tomorrow.
Okay, great. Everybody's still on that type of a pattern, right, at home?
Yeah.
Having to do both? Okay. I can flip the screen and you can fill it in. It just won't be the smart notes like I did before. It'll just be the same screen that you see. So it's up to you if you want me to flip over to the slides.
I've just been taking screenshots of them so that when I get my computer today, I can just fill it in.
Okay, so I'm gonna flip it over and let you see it, and then I'll flip back, okay?
Okay.
All right, here we go. Share, here we go. Okay. Do you at least get to see this one box right here? Because I can make it like this, hold on. Like that. Is that better?
Yeah, I can see it.
Okay. So basically, this is what we're going to be talking about now, is the biochemical components of the body and skin. So biochemistry is the branch of science that deals with the chemicals related to life processes and their reactions within the body. There are three major biochemical compound groups: your proteins, which help the body construct and renew itself; carbohydrates that are used by the body to store energy and play a key role in our metabolism; and lipids, from components that fill in the intercellular spaces in the skin. I know you've heard me talk about that intercellular glue. Basically what it is that liquid that goes in there and glues down the dead skin cells on top, so that we have to go back in there with stronger exfoliants to remove that glue, break it down so that the dead skin can come off of the skin. More, you might see it more on somebody that's my age, or maybe, you know, in their 50s or 60s and they haven't taken care of their skin. Then you'll see a lot of this, where that's where their skin looks dull, and you don't get an actual thorough cleanse unless you're doing some type of exfoliation. Okay, so this actually goes into your workbook exactly the way it's written on this page. So where it says the biochemistry part of your workbook, you're going to fill that in just like it is on this page. So let me know when you guys have gotten this in there, and then I will turn the page. This is still part of the tail end of the chemistry of matter. Once we hit the pH scale, that's where the fun's at. How would come out on the filling in your workbook? Can I turn my page?
Yeah.
Okay. So proteins, all right, basic materials the body uses to construct and renew itself. Skin, hair, muscles, nerves, and blood are all made of proteins. Many of our hormones and enzymes are made of proteins. So basically that first part where it says basic materials the body uses to construct and renew itself, that's all you have to put down in that area, okay, for your proteins. Your enzymes are materials that will dissolve and break down large molecules into smaller ones. Enzymes can be like our fruit acids, right? Break it down and break up all that dead skin. And then your amino acids are compounds that consist of carbon, oxygen, hydrogen, and nitrogen. You see it's missing one. It's missing that sulfur. They join together to form a protein chain in two ways. Okay, they form the peptide bond and the polypeptide chain. So once you fill in your amino acids and you get to the two blocks that you have on your, or if you only have one, do you have two or one where it says under the amino acids? Do you have one block on your study guide?
There's just 4 lines.
There's just 4 lines? Okay, so it doesn't have peptide bond and then it has another line that says polypeptide chain? No?
No.
Okay, so under the first line, after you filled in your amino acids, okay, you're going to put a peptide bond, and it's a bond uniting 2 amino acid groups, okay? A bond uniting 2 amino acid groups. And then under the next line, you're going to put a polypeptide chain, and this is just a chain of amino acids. Okay, you're going to have 2 more lines left, right? Can I change the page?
Yes.
Okay. All right, so here's basically what I just gave you, okay? A bond uniting 2 amino acids and the polypeptide chain, basically giving you a definition. So the next line, you're going to put monomers, M-O-N-O-M-E-R-S, okay? And your monomers are basic building block molecules that serve as building blocks that connect with each other to form larger, more complex compounds. Okay, and your polymers are going to be the groups of monomers that bond together. So those would have been your 4 lines that you had underneath your amino acids. You had peptide bond, polypeptide chain, monomers, and polymers. I can kind of give you an example as far as nails in our monomers and polymers. Our polymers are basically powders that we mix, and our monomers are the liquids that we mix together. So when you mix those 2 together, you actually make that acrylic nail. But it's giving you an example of how these work. Really can come up with one for our skin. I know I should have, but I just couldn't. Okay, I'm going to flip the page. All right, we're down to carbs, okay? These are used by the body to store energy and play a key role in metabolism. Examples of monomers and polymers that are found in the body. The carbohydrates are molecules containing a combination of carbon, hydrogen, and oxygen. A saccharide is a simple unit of a carbohydrate. Okay. A monosaccharide is a single saccharide. Disaccharides are two saccharides linked together. Okay. And polysaccharides are many saccharides linked together. And all this sounds like mumbo jumbo, huh? How about this? Under your monosaccharide, an example would be like sugar, like such as glucose. That would give you one example. Disaccharides are table sugar, and polysaccharides are going to be starch. That's the best I got. So did you get my examples?
Yeah.
Okay, good. Thank you, hon, for answering. Let me know when you guys are finished with this page, and then I will flip over to the next part of this. Just be glad I'm not asking you to write the 500-word essay after this.
Oh my God.
Yeah, because in your textbook it says it's like, if you were asked to write a 500-word essay on the topic you found most interesting, which one would it be?
Yeah.
Okay, hold on just a second. I forgot. Can you ask if she can print up or just find like 15 chapters for her? Of the key terms? 15. All 15 chapters. Yeah, she was supposed to call first. I told her that. Sorry, you guys. Okay, can I change the page?
I'm done.
Okay, how about you, Griselda?
Yes.
Okay, good, there we go. Lipids, this is the last part of this, okay? All right, lipids are made up of carbon, hydrogen, and oxygen, and are not formed by the linkage of basic molecule units. They're synthesized by the body and used in many important biological functions. They fill in the intercellular spaces in the skin. Triglycerides, fats, and steroids are all examples of lipids. Okay, we'd like to try and keep that lipid balance in our skin so that we don't turn out too dry, but we don't want it to sit up and build up like dead skin cells either. So, an example, well, they kind of give you your example. Your example on this one is your triglycerides, fats, and steroids. Okay, when you're finished with this, we're going to move to the learning word scramble. Okay. Can I turn the page?
I'm done.
Okay. Oops, our self-check was on this one. There we go. So anything that occupies space existing as a solid, liquid, or gas is termed as
Matter.
matter. Good. All of the following are elements that form the basis of hair, skin, and nails, except, which one do you think?
Helium.
Helium, right. Okay. True or false? Atoms have a nucleus containing protons and electrons.
False. Isn't it?
That's
Isn't
what-
it
Yeah,
proton? Yeah.
protons, neutrons, and electrons, right? All right, the chemical behavior of atom depends mostly on the number of blank in the outer shell. Okay, I'm gonna go back to that little note right here.
Electrons.
Yep, got it. All right, and name 3 major biochemical compound groups. We just went through it.
Proteins, carbohydrates, and lipids.
Good. Perfect. Okay, so match the term with the best description. Okay, so we have a peptide bond. All right, I'm going to read through here too. A negative charge with one amino acid grouping attracting a positive charge. You guys follow along with me here so that you can actually try and fill in the blank. Form an acid, one amino acid. Oh my gosh. I'll give you a hint, okay? The disulfide bond is the most important bond to a salon professional's work. Okay, I'll give you that one. A salt bond is
It's A for the salt bond.
okay. Then that means the hydrogen bond is going to be
C.
Yeah. Okay, and so the last one, the peptide is going to be formed when an acid end of one amino acid attaches to the other, to the amino acid of the other, correct?
Miss Jamie,
Yes.
Go ahead.
Diana said she's trying to get back in the Zoom.
Oh,
Her
okay.
computer had died.
All right, that's right. Let me just change screens here, okay? Hold on. Okay. There we go. It's a good thing you guys at least talking to each other because I can't see when I flip the screen. I don't even see your trying to get in. Have we got everybody though? 1, 2. Someone missing. Hi, Diana.
Hi, sorry, my laptop had died.
That's okay. That's okay. So is everyone back in here yet? 1, 2, 3, 4, 5, 6, 7. Right? 7, right? Okay. I think we got them all. All right. So were you able to fill in those little questionnaires? See if I can go back and get maybe fill them out again. So at least get the answers for it, right? Okay. Go. Okay. So anything that occupies space, right, is going to be matter. This is the answers. Come on, move. There we go. True or false? Atoms have a nucleus containing protons and electrons. I didn't even tell you that. We've said that one was false. The chemical behavior of the atom depends mostly on the number of electrons in the outer shell. And name 3 biochemical compounds. Quite, this thing is really messed up on this page, isn't it? The proteins, carbohydrates, and lipids. Okay. All right. Can you see the answers on this? The first one is B for peptide. Okay. C for the hydrogen bond. A for the salt bond. And D for the disulfide bond. Okay. This is just going over the same information we just went through. Okay, so now we've finished this particular chapter and we're gonna go into part 2, okay, which is gonna be your pH scale. Did you guys have the, let me stuff this right here. Do you have the Scrabble in your book?
Yeah.
Do you have this,
Yeah.
Okay, L. What, Angela? Oh, all right. I will give you a couple of minutes, 2 or 3 minutes. Do you like word scrabbles, or have you finished them already? You can see some of you have. I'll give you the first one. The first one's pretty easy, okay? How about carbohydrates? No, it's just saccharides, disaccharides. Okay, DISACCHARIDE. Okay, that's your first one. And then I'll let you, there's one L missing in one of these, I think. It's in F. Do you
Oh,
have an
that's
L
why
in
I
yours?
couldn't get it. I was super confused. I was like, what? I'm all counting
Missing
like,
an L.
I'm like, something's not right.
That's the only one that's missing a letter, okay?
I
tell
was
you guys
like
that.
there for like 10 minutes looking at it and focusing, and I'm like, I'm done. I can't do it. Because I did this like maybe like a month ago, but it was like, I don't know what to do.
I know. I didn't realize that either until the first time I taught this. Everyone's like, "There's missing a letter," and I'm like, "Oh, okay." Make sure I put it on there. I thought with you guys getting the newer books that it would have been on there, but I guess it's still out. Hey, Megan, I need to see your face, hon. Sorry. I know everybody's like, I'm in bed, I'm in my pillows, my pajamas. It's okay. We all are, except for me. I had to get dressed to come to school.
Let's
I could
just
do it
have
at home.
a pajama day, Miss Janie, just all of us.
We do at Christmas time. We do at Christmas time. So you'll be here during that particular time, so we'll make sure that you guys get to wear your pajamas.
That'll be fun.
There's an ugly sweater day. Okay, so don't forget about that one either. Quite a few. Like, yeah, we want to get this. I
And
don't
then
know what's
Miss
gonna
Janie,
happen.
my book, I ordered my books because I know that I was told that I didn't have to have like the hard copies, but I still
Right.
ordered them. But is that going to be an issue that they won't be here yet for tomorrow?
No, because I have another book here you can use. Okay. All right, don't worry about it. Someone else has one of my books too until they get their book, so I'm not really worried about it. Just as long as I get them back before you guys, graduate. That's when I have to have them back. The workbook, I don't have copies of that, but we'll get by. All right, how are you guys doing on your little Scrabbles? Is anyone else finished besides Jasmine?
I'm done.
I have them all, but I don't know why I can't figure out H.
H, biochemistry. Is it missing a letter?
Oh my goodness.
Yeah, it is. I couldn't figure that one out either.
It's
It's there.
Oh, then I'm
okay.
just
Perfect.
dyslexic.
Okay, so I'm going to go through these for you, okay? B is saccharide, okay? C is polymers. D is lipids. E is monomers. F is polysaccharides, because that was missing an L. G is proteins. H is biochemistry. I is monosaccharide. And J is carbohydrates. There we go. So now we're going to get to the fun stuff, okay? This is the fun stuff. So those of you that have this up, do you want me to set up the screen for you so you can see what the pH actually looks like? So let me switch screens again. Okay, hold on 1 second. Okay, I have to go back and get, okay, 7.2, come on up. It's slow, sorry. Okay. Coming up. Eventually. And now I'm frozen. Come on. Okay. Okay, here we go. All right, so let me share screens. Okay, and then present. There you go. Okay, and I have to go back one. Yep, there we go. Okay, so this is basically understanding the pH. And the pH means, or potential of hydrogen is what it means. It's the unit of measurement that will indicate whether a substance is acidic, neutral, or alkaline, because they fall within that 0 to 7, or 0 to 14 scale, with 7 being neutral. The pH numbers measure the amount of acid or alkaline in a water-based solution. So only solutions that contain water and or dissolve in water can be acidic or alkaline. So there is a test question that asks you, okay, about only solutions that contain water and or dissolve in water, okay, can be acidic or alkaline. So tomorrow, I'd like you guys to bring in a liquid that's part of your skincare, something at home that you're using, that's a liquid that we can actually measure the pH in it, okay? Because we want something that's more in the acid range, near a 4.5 to 5.5. So I'll bring in your little litmus papers and we can test things. Okay, what did you find out yesterday about your pH scales? Does anybody want to try and talk about that? Are you there with me? Hello?
What do you mean? Like, what did we find out? Like, what?
Yeah, what did
like,
you put down on your scale? Like, what did you start off with 0 and go higher?
Oh, okay. Well, I put gastric acid for 1.
Okay.
And then the egg was an 8, which I really didn't think an egg, would have a pH, but I guess that makes sense since it is like something.
Uh-huh.
And then the apple juice, which I kind of was not surprised because like I get like a stomach ache from apples, so that makes sense. It's like a 2. It's like a 3, yeah.
Yeah, that's where oranges are, yeah, too. Mm-hmm. Okay, anybody else? What did you find out on your pH scale? Did you guys do your pH scales? No one's answering me.
Yeah.
What about blood at like around 8?
What was?
Blood, I wasn't aware of that.
Yeah.
Blood's at 8.
You got an 8? What else did you guys find out on there?
I found everyday face soap is at 11.
Face soap? At an 11?
That's the one. That's something I found, yeah. And it said soap was at 12.
What do you think that does to the skin? Dry
If
it
it's
out.
Yeah.
It jacks it up.
Yeah, it does that too. But
It's you're gonna have like no skin. You're just gonna have like leather.
If you're saying 11 and 12 is for is soap, okay, and 14 is drain cleaner. Come on, look at that. Is that not bad?
11 and 12 is also ammonia.
See?
And bleach.
Yeah,
So.
yeah.
That's just disgusting.
That's
And
horrible.
then baking soda is a 9, which I can get, but like I'm like people like eat it. Like I don't know. It's used in a bunch of different stuff and it's supposed to be like healthy, but I'm like that's a little bit iffy.
Yeah, but you know there's supposed to be like when you eat something that's acid, it actually turns to alkaline in the body. It turns to be the opposite when you eat it.
I didn't know that. Okay, that's kind of cool.
It's kind of weird, but it's true. And I was like, And you're only supposed to, like, if you're eating, it's so that you don't get an upset stomach, if you're eating all acid type of foods or eating all alkaline. When you switch back and forth, that's why they tell you you should never eat like meat and potatoes together because one of them's like on the other end of the scale. So if you can actually pick foods that are in that same, like either acid or alkaline for your body, then you won't get like upset stomachs and stuff like that. And what you're really trying to do is you want to get, because your stomach has acid in it, right? Okay, so you're wanting to eat more alkaline foods, if you think about it. Distilled water is supposed to be like 7, but have you seen that they now sell alkaline water in like the health food stores?
Mhm.
You know, this is really kind of odd. I just realized this. People that have cancer, when they go to these cancer clinics and they start to give them a new diet, right? They all are drinking this alkaline water to settle out their stomachs, okay? Because that cancer actually infests through there. So if you had drank that water all your life, you wouldn't have half the problems because that type of water actually flushes everything out.
Well, that would have been nice to know, Miss Janie. Where were you when I needed you?
I just
Well, now you know you're still young.
I just recently found it out myself. I'm like, well, why are they, they should tell us that kind of stuff. But I want to make one little thing clear before you decide to go out there and buy like the 8.5 and the 9 point, the 10-point alkaline water, okay? If you have not drank that type of water, okay, start off with like a cup of it a day, okay? Otherwise, you're going to end up with the runs, all right? So you want to start off a little bit until your body adjusts to that alkaline water. The best I can tell you, when I've had a 10, that was the highest one I had, but I usually drink it at 8.5. But here's what's going on. If you've ever been up to the mountains, like been up to Mammoth, I know up at Mammoth, the water that comes off those rocks from the snow, it's clear, right? I mean, I literally, when we went fishing, I could pick up the fish with my hand. That's how clear the water was. I was standing in it. Cold water, but it was clear. So
Have you done that? Because that would be
yeah.
amazing. Oh my God.
Like, it's not legal. You're not supposed to be, you're supposed to catch them, you're not supposed to get a net, just grab them. Because that's how easy it was to get them. They were right somewhere between your legs and you can see them. It's not like any of the waters you can see around here. But anyways, if you have ever drank that type of water, because it feels like it's coming off a rock, kind of like I don't know how to say it. It's not dirty water, but it feels crisp or tastes, it just has a little different flavor to it. Okay, that's what that alkaline water kind of tastes like. Okay.
It's a little bit spicy.
Yeah, I have to drink it very cold, but I have to drink my own water. I'm always freezing my bottles of water, so in order to get me to drink all of it, it has to be very cold, otherwise I won't drink it. But the same thing for that water. So you can drink that type of water and see what happens. But start off with a glass a day and build your tolerance up, and then go for whatever you were drinking for the rest of the day. Like if you were drinking like 6 bottles or 4 bottles or whatever, build your tolerance up to it. Don't just start off, I'm going to drink 4 bottles of this a day.
So it can help like stomach issues then. Like,
yeah, it does help. It does help with a lot of stuff, but that's what they do when they send you to these expensive little, cancer treatment places, because they do a whole new diet for you, right? And start to prepare your foods so that you're eating the right foods to kill the cancer as best you can. They don't tell you that when you're like at Kaiser, okay? They just don't tell you that kind of
yeah, they
stuff.
didn't tell me that either, so.
You're right, but it's true.
I'm just now learning this in beauty school 7 years later. Thank you.
Must have been nice, huh? Okay, so going back to our acids and alkalines, okay? On your acid one, okay, what I want you to put down is it has more positive hydrogen ions, okay? More positive hydrogen ions than negative ones. But if you think about it, an acid already is. When I told you how your galvanic work, right? Your positive is an acid. So that's how you remember that one. And your alkaline, I've already told you it's negative in your galvanic. So alkaline is going to be more negative hydroxide ions. So you have more positive hydrogen ions, and then alkaline, more negative hydroxide ions. Okay, so your next area is going to be the pH scale, okay? And what you're going to write in there, it ranges from 0 to 14, okay? And describes the degree of acidity or alkalinity. So it ranges between 0 to 14 and describes the degree of acidity or alkalinity. Okay, with 7 being your like neutral point. So there's a test question that asks about this. And it says something about the pH scale is from 0 to 14, and 0 to 7 is an acid. Okay, but it isn't, remember, because acid goes 0 to 6.99. So that would be a false statement, okay? I just want you to make sure you're reading it. Yeah, make sure you're reading it. All right, right below that is this pH scale is logarithmic, which basically means each number increases by multitudes of 10. So this is how it's going to work. If you look at your scale, and it actually has 7, and it doesn't have anything until you get to the 8, right? Okay, 7 being my midpoint. If my product went from 7 to 8, that's 10 times stronger. 8 is 10 times stronger than 7, okay? Then when I get to 9, it's asking you between 7 and 9. That's where you add another 0, and it's going to be 100 times, okay? 7 to 10, it's going to be another 0 you add to it, and it's going to be 1,000 times stronger. I'm trying to read your little thing so you understand what they're talking about. So the test question is always going to ask you, you know, how do you multiply it? And it's always multiplied by 10, okay? Each number. Now this isn't on your book, but I want you to write this in so you can understand. If you went the other way, to the acid side, okay? 7 to 6 would be 10 times, okay? So under the 6, you would put 10 times, okay? Then you go 7 to 5, and that's going to be 100 times, okay? And then 7 to 4, it's going to be 1,000 times. So each number going lower is going to add another 0 to that same number, okay? Just like it does on the other side.
So is 7 0 then technically, or?
Yeah, like 1, 2, 3, 4. Yeah, there's 7 at the very end on that 1 or 0. Excuse me, 0 would have been, yeah. That's where you put it. So here's what you're looking at. The same thing again, like this. Okay, the strongest acid and strongest alkaline are going to be on the very ends, right? The 0 and the 14. Okay, but as you add water to each of them, it brings it back like this, so that 7's in the middle. That's kind of cruel. My hand's like slow motion. Okay, so you understand what I'm talking about though, right? Okay, and you can complete it all the way over to the 0, all right, with your zeros on there. But that's what they're trying to tell you. Your acid's going to go just the same way as your alkaline did, but you're going to go lower. Okay, cool. All right, pH balance on your workbook, okay, or acid balanced, okay? So let me read this before I ask you to put that in there. pH balance basically means it's balanced at a certain pH, okay? So write that right next to where it says pH balanced or, okay? pH balance means pH balanced at a certain number. Doesn't necessarily mean 4.5 to 5.5, okay? That's what I always say. It's like, it says it's pH balanced. Well, pH balanced to what? You don't know what it's balanced to. It just tells you. So that's not really a good product if it's not going to tell you what it's balanced at. However, acid balance means that it's balanced between the acid range of 4.5 to 5.5. Okay? So skincare products will be your acid balanced. All right? pH balance does not mean 4.5 to 5.5. Only acid balance does. Did you have a question on that one? Anyone? No. So even if you're looking for hair products, okay, you want your hair products to stay on their acid balance, okay? So it's going to clean without stripping. But if it says pH balanced, you're going, what is it balanced to? It could be balanced to 12 or 11 or something like that. You don't know. Okay, because we work with products that actually interact with our skin, we want to not disrupt it as much as possible. Still be able to do the job of cleansing without stripping it. So did everybody get that in there? All right. Your acid mantle. Basically, this is a mixture of sebum and sweat, okay? And then it's got a little bit of lipids and minerals and moisture and all that kind of stuff. But basically, it's sweat and sebum. And it leaves like a protective barrier on top of your skin. And it's there to protect your skin from the outside elements, like dirt and grime getting into your face, okay? So it aids in protecting you from outside elements. I like to think of it as leaving a perfect balance for you, okay? I think that's why they call it the acid mantle. And the best way to describe it is a little mister at the grocery store. You know, when the vegetables get sprayed every like 15 minutes, they spray them and they look all pretty and green and fresh, right? Well, your body does the same thing. It mists out this liquid sebum and oil together and makes that protective barrier. That's that kind of shine that you get right after you've gotten out of the shower. Maybe you glue dry your face and or your hair, excuse me, and then you got that nice little glow on your face, right? That's what that is, that acid mantle. And that's there. It's a good thing. Okay, you're supposed to have that, but we've been brainwashed into thinking that our face should be matte and not have any oil on there. Okay, but it is healthy to have a little bit of that oil up there to protect you. When you strip all of that off, then the skin is more susceptible to getting infections or anything else getting inside there to cause the dirt and grime to get past that. Okay, so we like to leave the acid mantle intact.
Miss Janie, are you watching Friends in the background or something on the TV?
Am I watching what?
I hear Friends like in the background or something.
Oh, no. Is it one of you girls? Because I don't have a TV on at all. And she has a nail grinder going on. That's about it.
That might be it, and I might just be imagining things.
Okay. Yeah, that's basically not what I got on here. Okay. So I'm going to leave you off right here. Okay, because I want to start with the water and the pH tomorrow. All right. But I can't really because I'm going to give it to you for homework tomorrow. But tonight, okay, I'd like you to practice, even though you don't have your stuff, could you practice manipulations or the best you can look over your notes to practice for tomorrow as you practice with me? You can, Megan, you're not gonna be able to do this until you come in tomorrow, so I can give you a list of things to get together, okay? So don't worry about it. The rest of you, I'd like you to practice. Do you have anything at home that you could practice on? A person? I'm like animal dog. Anyone that you can actually practice your manipulations on, okay? No, yeah? If you got somebody that you can practice on, take a picture of them. Setting up on your bed. Like it looks like you're going to do a facial on, okay? Make sure that your workbook is completed at least up until where we finished off at the acid mantle. And then check to see from 7.1 that it's finished and you've done the test on that, the challenge, okay? So make sure you go back to the work part of that and make sure it's finished. Does everybody know how to go back to that page? Yeah, Diana, how about you? Yeah?
Yeah.
Megan, are you comfortable with that?
Yeah, I think I could figure it out.
If not, I can go back and show you how to get back on there again. That's why I'm asking.
It's okay. I'll figure it out. I think I got it.
That's your homework, okay? You're gonna have to take a picture of the screen even though I'm gonna get the test, okay? Once you take that test, take a picture of it and send it to me. This is on, today's gonna be the last day I'm gonna give you those 2 hours. So if you're gonna take them today, all right? So do the assignment on there, whatever it says, kind of went through it here. You don't have to go through 7.2 yet, but 7.1 has to be done, okay?
Okay.
All right. Anytime you
So we are doing the additional hours today or just the 6?
You can get the 2 by doing the rest of the stuff that's on 7.1.
Oh, okay, got it.
The discussion, yeah, that part. All right, and taking the challenge. That will give you your homework. Okay? All right then, ladies. I guess we are finished for the day. Okay, and I will see you tomorrow, 8 o'clock. Right? Okay. Thank you, guys. Bye.
Thank you.